partial decomposition of fractions. So I guess the first thing we've got to figure out is what that even means. So let's backtrack. And if I had 3/7 plus, I don't know, 5/9. I'll zoom in on that. How do you combine those fractions? What do you have to have? Which is what? All right, so I'd have to times this one by 9, and I'd have to times this one by 7. So then we would end up with, let's see, 63, and I've got 27 plus 35. What's 27 plus 35?
60.
So 62 over 63. So we just took two fractions and made a new one, right? Oh. Thanks. So what we're doing today is we're taking a fraction, there it is, and we're saying, okay, go backwards. What two fractions did we add to get there? And that's something we've never done before, right? But that's what's going on. We're taking the fraction and we're decomposing it, breaking it into its parts. It's going to be okay, Katie. It's going to be okay. It will be all right. Now, the next thing that is a big jump, and it doesn't feel like a big jump, but it kind of is a big jump, is this guy right here. Now, what that's saying, here's this equal sign, right? So I've got an x squared, I have an x, and I have a constant. So if these are truly equal to each other, isn't whatever's in front of the x squared going to have the same value? Whatever's in front of the x is going to have the same value, and our constants would also be equal. That's a big deal today. So it doesn't feel like something we would trip up on, but we do. So going back to decomposing this fraction, right? What two numbers do I know go into 63? 7 and 9, right? And then we could end up working backwards. But of course, they're not just going to give us multiplication facts. They're going to give us polynomials and stuff like that. So I have got to look at the factors of my denominator. So factor that guy. Yep, it's a difference of squares. So I've got x plus 1, x minus 1, right? So what I know is that this fraction is going to equal some number over x plus 1 plus another number over x minus 1, just like our 63 would have broken into 7 and 9. Okay? So now I have this equation that I need to solve. Now, I like to get rid of fractions, and I recommend getting rid of fractions on these. Do you remember how to get rid of fractions? So, yes, I could times them by the reciprocal, but then I'll end up with an ugly numerator. So we're going to do something a little bit different. I look for the least common multiple of my denominator, which is technically my common denominator, which in this case is x squared minus 1. So we're going to times every term by that x squared minus 1. And sometimes I like to use it in the factored form, which maybe I should have here. In fact, I'm going to do that so we can see it a little bit better. So this is a what? We said an x plus 1 and an x minus 1. And an x plus 1 and an x minus 1. And then this is the fun part, because I get to go through and I cancel things that I have in common, right? gone, and then gone, and gone. So we are left with 6 equals a times x plus 1 plus b. Did I cancel? That one should have been a minus, shouldn't it? Yep. I had my, I wrote that wrong. Plus b times x plus 1. All right, distribute everything through. 6 equals ax minus a plus bx plus b. Then group like terms. All right, so now we're going to group like terms. And what I mean by that is we're going to put the something x's together.
Is it minus? Why is it minus?
Why do I keep losing my signs? It's a good thing you guys have me. No, it's a good thing I have you. Thank you. That was a good save. I would have messed up the whole problem, so thank you. I'm going to group my x terms together, and I'm going to group my, these don't look like constants, but they don't have my variable x next to them, right? All right, so I'll put the ax plus bx together. I'm just going to put parentheses around them so my eye can see that they go together. And then I'm going to put the plus, I've got a negative a and a b together. I'm going to factor out the x, and I'm left with a plus b. Nothing to factor out here. This is your constant term. And this is your x term. Now, looking on the other side of the equal sign, and that's where we're going to have what we talked about earlier come into play. So, on my left-hand side, I have a constant term, don't I? Do I have an x term? I don't. You don't need to do this, but for the sake of us learning and talking about it, doesn't that mean exactly the same thing? 0 times anything is 0, right? So I haven't changed the value of my polynomial at all. But now, remember when we said whatever's in front of the x's is equal to each other? Whatever is in the constant place are equal to each other? So guess what a plus b equals? Yeah. All right. So we've got a plus b equals 0. And then what else do we know? Negative a plus b equals 6. I've got a system of equations that I can now solve. All right, so we've already figured that out. Our a's cancel. 2b is 6, so b is 3. Which means right here, right away, a is what? 3 plus what is 0? So negative 3? That's not your answer. I mean, we're done, but that's not how we get to return our answer. So that's what I was going to say next, is you need to go back and you need to make sure that you put your a value over the x plus 1. So we would have negative 3 over x plus 1, and then we had plus 3 over x minus 1. We have decomposed our fractions. Now that's the first time you saw it. I made sign mistakes. That was my fault. I apologize. Let's do another one and make it cleaner. I didn't realize that I had two of the same problem on there, so there's a new one for you. All right, so anybody remember the first thing we did? That was a long time ago. Yeah, we're going to factor up that bottom, right? So I've got a greatest common factor. So I've got x over, or x times x plus 2. We'll work with it in factor form. How many factors do I have down there? 1, 2. So I know I'm going to have an A and B, which that's a little foreshadowing, because what do you think is going to happen here in a minute? We're going to have more factors, right? Okay, so I've got A over, what's your first factor? X plus B over x plus 2. What do we do next? Yeah, let's get rid of our fractions, so we'll times everything by that common denominator in this case. So x plus 2 times x plus 2 times x plus 2. And this is like my favorite part. I don't know why, but it is. It just feels so good. I'll give you a second to get there before I go on. All right, so we are left with, let's see if I can do this without making any sign errors. A times x plus 2 plus b times x. How'd I do this time? Am I doing a little better? All right, let's distribute that. Ax plus 2a plus bx. Then what happens? Rearrange. Yeah, group your terms together. Left hand stays on course, and I've got ax plus bx, and then I've got this 2a over there all by itself. Why do I know this is a constant term?
Because it doesn't have a factor.
Doesn't have our variable, right? It doesn't have x. I like to factor out that x because it feels so much better. And sometimes I like to write it like this with the x at the back. Now what do we know? By our equality property, what do we know?
A plus B equals -2.
A plus B equals -2. Ask. That's in front of an x, that's in front of an x, and because we're equal, those have to equal each other. Did that help? Lining it up that way? Okay. And likewise, this is a constant without a variable. This is also our constant without a variable, so we know 2a equals what? 2a equals 6. So yes, a equals 3. A equals 3, so then if I plug that in over here, 3 plus b equals -2, b is -5. So then we would make sure we return our answer that I've got, right? A is over x, so 3 over x plus our b was -5 over x plus 2. Now, our next two problems are similar but different. This one ends up with a squared term. You don't have that yet because I gave us some new ones. Let's see. Let's go ahead and do this one. Factor that one. What do we get? Oh yeah, it's an x squared. Oh, this one is different, folks. And x minus 3? How many factors do we have? And I am misleading you here. How many factors do we have? There are 3. Why are there 3? I only see 2. Does x go into x squared? Yeah. Does x squared go into x squared? And then I also had my factor of x minus 3. So I have 3 factors here. Yep. So we've got a over, should we go with x since we said that first? Plus b over x squared plus c over x minus 3.
Why do you have x squared?
Because x squared can also be divided by x squared. So it is also a factor. It's a repeated factor, x and x times x. What do we do next? Oh, go ahead.
With x cubed, would there be 4 factors?
If that had been an x cubed, we would have 4 factors, yes.
It'd be x squared, and x cubed.
Yep, all of those, yep. All right, what do we do next? Let's get rid of fractions. So we'll times everything by x squared, x minus 3. And some of you will be able to do this step in your head. You don't need to write it down to see it, and I love that. Stick with it. Gone, 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 gone. Just the squared is gone here. Gone, 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 gone. So we have negative 9 equals a times x minus 3 plus b times x minus 3 plus cx squared. What next? Yes, sir.
Would it be ax, within parentheses, ax minus 3a?
So tell me one more time.
So on that first one, would you put a to everything or just the first x?
We only distribute across pluses and minuses, right? So I can technically do my ax and then distribute it across that difference right there. That's a good question. Good question. So negative 9 is what? Ax squared minus 3ax plus bx minus 3b plus cx squared. It's so much fun. Don't you love learning new things, though? It's been a minute since we've learned something solidly new. And then what? I group. All right. Are you guys okay if I factor while I'm grouping? No? I've got this x squared and I have this x squared, right? So can I right now just say that's a plus c x squared? All right. And then what do we have? This one and this one? So can I say that's plus and negative 3a plus bx? And then what's my constant?
Negative 3.
Negative 3b. Oh, I only have what on the left-hand side of my equation? Just my constant, right? Just my constant. If it makes you feel better, put these there. Okay, if that makes you feel better, remind yourself that I have zeros over here. And then I can make that next jump of what? A plus C equals 0. Negative 3A plus B equals 0. And we also have negative 3B equals negative 9. And you're solving it. I hear what you're saying. So B is 3. Waiting. I would love for you to ask because you can't be the only one with the question.
Yeah, well, I thought A plus C was negative 3 because that's in front of the.
A plus C is next to the x squared.
Yeah.
And because I don't have an x squared term, it equals 0. All right. Who solved my A already? A is 1, which means C is negative 1. And Mia, you're probably good after that one unless you want to see one more. All right, so then, right, to return my answer, I would have 1 over x plus, what's my b? 3 over x squared plus negative 1 over x minus 3. I'm feeling like we got to do another one. No? I think we should. Does anybody want to see another one? Yes. All right. I gave us a different one because I didn't like the one that was there. So let me write that clearer.
There's no extra over here. There's nothing with an extra here. Well, it's just roll. I think, I'm not. It's like, I think this whole thing equals 12. Because it's the constant. You get up the x term, the third is the end, and then 12 is the constant. So this whole thing is.
All right. So
Will
will my students who are beginning to work just whisper while we finish recording the lesson? Thank you. All right, so if I factor this, x squared minus 4x plus 4, two numbers that multiply to be 4 but add to be negative 2. That, I like to write it like this, because then it kind of will tie into what we did in the last problem. So we have factored all the way to down here. So how many factors do we have? X?
3.
Yeah, 3. And then we have x minus 2. And then we have x minus 2 squared. So 3 different factors.
Will you generally have as many factors as the
Degree?
degree of the denominator?
That's a good way to look at it. Yeah, because we would have 3 zeros, right?
Right.
So a over x plus b over x minus 2 plus c over x minus 2 squared. What's our next step? Get rid of fractions, right? X minus 2 squared. X minus 2 squared. X minus 2 squared. X x minus 2 squared. My favorite part, gone, gone. So this is all gone. Gone, gone, gone. Got rid of the squared. Gone, gone. So I have x minus 12 equals a times x minus 2 squared plus bx times x minus 2 plus cx. Aren't you guys glad I saved this for today and we didn't do both things yesterday? Me too. Okay, don't let this kill you. Don't put x squared plus 4, right? Don't do that. X minus 12 equals a times x squared plus, nope. I don't want to lose that, so guess what I'm going to do? I'm going to erase it. Minus 4x plus 4 plus bx squared minus 2bx plus cx. X minus 12 equals ax squared minus 4ax plus 4a. There's a whole lot of writing going on. But then what? X minus 12 equals, I am going to group my squared terms together. So I've got a plus b x squared. We'll group our x terms together. So then I have plus negative 4, a minus 2b plus c x. Questions? I'm kind of just working through this one. Good. And then I have plus 4a. I have an x squared term here, but I don't have one here. If you need to see it, add it there. Okay, 0x squared. So then what do we know? A plus b equals what? 0. Why did I put a parenthesis? We'll add it over there. And then I have this big, long one this time. I've got negative 4a minus 2b plus c. It's in front of my x term. What's in front of my x term? What value over here? How many x's do we have? 1. And then we also have 4a equals my constant term, negative 12. So what does our a equal? Negative 3. So what does our b equal? Positive 3. So then we can back substitute in. Negative 4 times negative 3 is 12. Negative 2 times 3 is negative 6. Plus c equals 1. 6 plus c equals 1. So c is negative 5.
Where'd you put 12?
So I did negative 4 times my a term. There's my 12. And then a negative 2 times my 3 is negative 6.
Yeah, but like where'd you, like you just did 6 plus c equals 1?
12 minus 6.
Oh,
Just simplifying.
yeah.
It's all right. There's a lot of stuff going on right there. So then return a over x. Negative 3 over x plus b over x minus 2. b was what? 3. And then plus our c term, which was negative 5 over x minus 2 squared. Now, I do want to point out, I don't know if Alex will say simplify your signs. See how I have a plus, a minus right here? Everybody, eyes up here, just because I want to make sure that we get it right if Alex yells at you. Could this be a minus 5 over x minus 2 squared? That's technically more simplified, so I just didn't want you to not know what was going on if it told you to return it in a simpler format. Okay? Does anybody want to see one more? Okay, the only different thing on this problem, do you see how this one has an x squared term? That means we're not going to have a 0x squared on the left-hand side, right? You're going to have your x squared term equals 1.
And no x.
And no x term, so it would equal 0. Wowza, that's fun stuff.
What is it used for in